So this is going to be the 5-4 video on solving right triangles, which is something that you did in geometry. We're just going to refresh your memory and kind of remind you how to do it. And this video is really going to be based on slides 1 through 6, okay? Slides 7 and 8 were added here, but they really don't go with this section. They really go with section 5.3. And so I've created a separate video for 5.3 Part C, and that's where you're going to find the work and everything, the examples worked out for the slides 7 and 8 of this video. So I'm going to focus on slides 1 through 6, and that's what this recording is going to be all about. So when we use SOHCAHTOA to solve triangles, what we want to do is label our triangle, and we want to identify, obviously capital letters are our angles, so we might have, for example, angles A, B, and C, and then we use lowercase letters for the sides. So if I create a triangle here, right, I always label the right triangle, the right angle, the C value, and I label my acute angles A and B. And then the sides, I'm going to use lowercase. So for me, I use little a, little b, and little c. And so I sort of think of right triangles, the Pythagorean theorem. A and B refer to the legs. So the leg opposite the A, well, that's little a. The leg opposite the angle B is little b. And the leg that's opposite the angle C, which is your hypotenuse, we always refer to that as little c. And so I always label my triangles so I know exactly what angle and what is opposite and adjacent to that particular angle, okay? And so again, we know sine is opposite side or leg over hypotenuse. The cosine is the adjacent leg over the hypotenuse. And the tangent is the opposite leg over the adjacent leg. Just remember that opposite and adjacent always refer to legs, never the hypotenuse, okay? And again, when you're solving, what you're going to do is you're going to find all the missing angles, which again is going to be angle A and angle B, and then all the sides, which could be little a, little b, or little c, depending on what you've been given. So when I come over here to this example, it says solve the right triangle, round answers to the nearest tenth. Now notice they put A and B, angles A and B, different than me, but they still refer to the two acute angles, and the right angle is still angle C. So I know that in this triangle, little a is side BC, right? Little b is side AC, and the hypotenuse, again, is C. So I have to look at what they've given me, and in this triangle, they gave me angle A, which is 31.67 degrees, and they gave me little a, which is the length of the side opposite it, which is 35.9. They want me to round all my answers to the nearest tenth, and they want me to solve the triangle. So the first thing I'm going to do is I'm going to solve the triangle using the angle that they gave me. I know that angle A plus angle B have to add up to 90 degrees because angle C is 90, and together that equals 180. So if angle A is 31.67 plus angle B is 90, right, let's sub it in. If I subtract 31.67 from both sides, I'm going to get exactly what angle B is. Now you guys have a calculator so you can use it, but be careful. If you're going to subtract it on your own, make sure that you write those extra zeros, and you're going to get 58.33 degrees. Now it wants it to the nearest tenth, so that's 58.3 degrees. Okay, so I try not to, if they give me to the hundredths, I try to do the math with the hundredths and then round at the end, right? So I know, again, angle A, when I round it, is going to be 31.7 degrees. Angle B, when I do the math, right, I'm going to get 58.3 degrees. So I've got that now. And now I'm ready to find my two missing side lengths. Now, if I happen to have been given, right, if I had been given side A and side B, or side A and C, if I had been given two of the three, I could have done the Pythagorean theorem here. If this was a special right triangle, 30, 60, 90, or 45, 45, 90, I could have used what I know about those. But because I was only given one side, I'm going to have to mathematically calculate my missing sides. So as a strategy for me, I try to use the information that was given to me. Like, in other words, I try to use the information given rather than my number that I did. Like, just in case I added wrong, I try to avoid using the angle I came up with. So what I see is that I have angle A, I have the opposite of angle A, and I'm looking for hypotenuse and I'm looking for adjacent. So I'm going to start with the sine of angle A. Okay, I know that the sine of angle A equals opposite leg over hypotenuse. So the sine of 31.67 degrees equals the opposite leg, which is 35.9, right, over the hypotenuse, which is C. So notice I have two of the three values. I've got the sine of the angle, I have the opposite, and the only thing missing is hypotenuse. So I could mathematically solve for C. I'm going to multiply both sides by C. That's going to give me C times the sine of 31.67 equals 35.9. And then if I just divide both sides by sine of 31.67, I'm going to get my answer. Notice that I just kind of been manipulating the equation. I haven't typed anything into my calculator. Now I go to my calculator and I do that. And it's going to be 35.9 divided by, I put it in parentheses, the sine of 31.67 equals, right? And I'm going to get my answer. And I'm going to get that C equals 68.37, which again rounds to 68.4. So now I know side for little a is 35.9. That was given. Side B I haven't figured out yet, but side C is going to be 68.4. And these are all in kilometers, so I might as well write those units of measure. Okay, and so now all I have left is finding side B now. So again, I kind of go to my picture and I look, and again, I know that I was given angle A and I was given the side opposite angle A. So I'm going to try to use that to find little b, which is missing. Well, little b is adjacent. So I know that the tangent of 31.67 degrees equals opposite over adjacent, which is little b. And again, I can solve here. Let me just kind of separate this, right? I can solve here by solving for b. So I'll multiply both sides by b. That's going to cancel that out. I'll divide both sides by the tangent of 31.67, and then I will plug this into my calculator. And I'm going to get, I don't know why I do 3.59, it's 35.9. I don't know why I keep writing that. But I'm going to get, the math is going to be 58.195. And again, I have to round this to the nearest tenth, so I just have to look at this number, the 9, and I know it's going to be 58.2 kilometers. And again, I ask myself, does that make sense, right? Is the hypotenuse the longest of the three sides? It is, and so again, I know that that's probably correct. Now, some of you might be thinking, well, the math was a little bit difficult because the variable in both of my cases, the hypotenuse, was in the denominator spot, you know, so that was what I was looking for. That was my variable. And then when I did the other one, in the tangent, the b, which is what I was looking for, side b, was also in the denominator. Had I chosen to use angle b, my setup would have been a little different, because if I had used angle b, for example, to find, let's say, side b, that was opposite. So I could have done the tangent of 58.3 is equal to the opposite b over the adjacent 35.9. And when I had done the work to solve, right, notice I would have been able to solve for b just by doing this math. Okay, so yes, it is easier sometimes when the variable is in the numerator spot rather than the denominator. And if you're very sure that you did your math correctly, you could use the other angle to find that. I just am hesitant to tell you that because, again, if you made a mistake on this angle, all your values are going to be incorrect. So, again, yes, there's easier ways to solve depending on the angle you use. Just make sure if you're going to use a different angle than the given angle, right, which is foolproof, make sure that you did your math correctly. And so anyway, now you get back and you realize we solved the triangle. Remember, angle C is 90. That one's always 90. But basically, all your angles are here. Make sure they all add up to 180, and all your three sides are here. So the triangle has been solved. When I come over to this slide, again, solve the right triangle, round the answers to the nearest tenth. Again, I'm going to just, oh, well, they drew the triangle. I don't have to draw it, right? So they said angle B is 47.8, and little c, which is the hypotenuse, is 89.6 centimeters. So I know little a is over here, little b is over on this side. And again, let's kind of start doing our setup. I know I'm going to need to know angle A, angle B, and angle C, which I already know C is 90. I know B is 47.8. And this one's the easiest of all to solve. I'm just going to do 90 minus 47.8. And again, guys, just make sure you do the math correctly. I know the answer. I pretty much do this in my head. However, if you have a calculator, we're allowing you to use it. Why take the chance, right? So I just plugged it in and made sure that it's 42.2 degrees. And so again, I know this is accurate. I can double or triple check it. Once I do, I know I can use angle A or angle B for my math, depending on which math is easier for me at the time. So again, if I'm looking, for example, for little b, I could use the given information. They gave me angle B. This is the opposite of angle B, and this is the hypotenuse. So again, I know that the sine of angle B equals little b over the hypotenuse. So the sine of 47.8 equals little b, which is unknown, over the hypotenuse, which is 89.6. Because the variable's in the numerator spot, this is a really easy problem to solve. I just have to multiply both sides by 89.6. So I'll come to my calculator, 47.8, I'll find the sine of that number, and then I will multiply that sine by 89.6, and I'll get that little b equals 66.37, and because they want me rounding, it's going to be 66.4. So little a is unknown, little b is 66.4 centimeters, and little c was given at 89.6 centimeters. So again, now I'm going to try to figure out how I'm going to find little a, right? Well, little a is the adjacent side, and this is the hypotenuse. So again, I know that if I do the cosine of angle B, that's going to be adjacent over hypotenuse. So I'm going to plug in. So cosine of 47.8 equals little a over 89.6. Yet again, to solve for the variable, I've got to multiply both sides by this denominator. And so again, you're going to get your calculator, you're going to find the cosine of 47.8, and you're going to multiply it by 89.6. And you're going to get A equals 60.186. And again, we're rounding to the nearest tenth, so it's 60.2. So 60.2 centimeters. And again, I always look to see, is my hypotenuse the longest side? And it is, so I probably did the work right. And here are your three solutions. Again, make sure that you list your unit of measure and you label your angles using the degree symbols, okay? Don't leave them out of that. Now, sometimes they might give you some values and they may ask you to find the measures, but they don't give you the drawing. So again, just make sure you know how to insert the drawing, right? So again, it doesn't have to be beautiful or anything. It doesn't even have to be to scale. Bottom line is just label three sides. I'll do, A, here's B, and here's C, however you want to do it. I know little b comes across from big B, little a is across from angle A, and I know that the hypotenuse is C. So I'll plug in what they gave me. They said angle A was 61 degrees, and little b is 39.2 centimeters. Okay, so again, I'm looking for angle A, which they told me was 61. I'm looking for angle B, and I'm looking for angle C. Angle C is the right angle, always the right angle. If angle A is 61 degrees, I know B is complementary. It's 90 minus 61 degrees. So it's going to be 29 degrees. And so again, I'm able to find an additional value here. And now I can use angle A or B to find what I'm looking for, depending on what works better, right? So I know that I've got, for example, I'm looking for, let's say, little a, right? Well, little a is the opposite of this side, and this is the adjacent. So if I were to do tangent of angle A, it would be little a over little b, opposite over adjacent. So let's do that. Tangent of 61 equals opposite over adjacent. And again, notice the variable is in the numerator spot, which is the easiest way to have it. Just multiply by my denominator, and I'm going to get my answer. So I'll find the tangent of 61 degrees, and I'll multiply that by 39.2. And I'm going to get that little a equals 70.718, which again, I'm rounding to the nearest tenth, so it's 70.7, and it's centimeters. So I come over to here, again, I'm looking for little a, little b, and little c. Little b was given to us, right? Little a I just found, 70.7 centimeters, and now I need to find little c, right? So once again, I come over here and try to figure out. Now again, like I told you, I try to use what's been given to me, and because they gave me b and they gave me a, I like to stick with that. And so I know that the cosine of a equals the adjacent side over the hypotenuse, which is c. So I'm going to plug it in. Cosine of 61 equals adjacent, 39.2 over c. Now again, because I have a variable in the denominator, the math is a little bit more of a pain, but it's not super hard, okay? It's basically going to be, I multiply both sides by c, and then I divide by cosine of 61. So I'm going to get c equals 39.2 divided by cosine of 61. If you wanted to use b, you could do, for example, you might be able to, could I find an easier way to do it? No, the hypotenuse is always going to be on the bottom, so there's really no easier way to do this one. So I'm ready to just solve. So I'm going to come over to here, and I'm going to do 39.2 divided by, and then be very careful. I'm dividing by the cosine of 61, and I should get that it is approximately equal to 80.856, and since I have to round to the nearest tenth, it's 80.9. And so 80.9 centimeters. Again, notice that I've identified my units of measure, which is important. Notice my hypotenuse is the longest side, which should be the case. And again, notice that I've identified all my angles with degree measures. So all of this work here all relates to number 3, right? So I'm going to kind of erase this work, and I'm going to jump in and do number 4, okay? So again, all of this work, those are the answers for number 3. When I get to 4, again, I draw my triangle and label it accordingly. Again, you're going to, you may make certain angles A, B, and C. It doesn't have to be to scale. Again, they told me that angle B is 46 degrees, side C, so this is little a, little b, and little c. So the hypotenuse is 29.7 meters. Again, I've got angle A I'm looking for, angle B, angle C is always 90 in these problems. Then I have little a, little b, and little c. I was given B is 46 degrees and little c is 29.7 meters. So again, the easiest one to solve for here obviously is angle A. 90 minus 46 is 44 degrees. So I know that angle A is 44. Always check with your calculator just to double check and make sure you did the math correctly. Now I'm ready to use my trig functions to figure out A and B. So I can pick and choose again. I've got the hypotenuse, which is great because I know that when I'm solving, when I have the hypotenuse, if I use sine or cosine, then I'm going to have the 29.7 or the hypotenuse value in the denominator, which is going to be nice. So because they gave me B, I'm going to stick with that. Okay, so let's say I'm looking for little a and they gave me angle B, I know that little a is the adjacent side and C is the hypotenuse. So if I come over here and do the cosine of 46 degrees, it's going to be the adjacent side over the hypotenuse. And again, because the denominator is the number, 29.7, as opposed to the variable, this is like kind of the easiest it's going to get. these cancel. So if I just take my calculator and do 29.7 times the cosine of 46, I'm going to get my A value. So little a is equal to, when I do the math, 20.63, and I have to round to the nearest tenth, so I know it's 20.6. So little a is 20.6 meters. And then now I'm going to solve for little b. Now little b here, or side b, right, is opposite of angle b. And again, I'm going to stick with using angle b. So I know the sine of angle b is going to be the opposite leg, which is little b, over the hypotenuse, which is 29.7. So again, multiply both sides by 29.7. And I'm going to get that b is approximately equal to 21.36. And since they want it rounded to the nearest tenth, it's going to be 21.4. So 21.4 meters. And now that I have all my answers, I check them. Make sure that your hypotenuse is the longest side, and it is. Make sure that you have the unit of measure, meters, listed. And make sure that your degree measures all have the degree symbol. And if you want to double check, add 44 plus 46 plus 90 and make sure that they all add up to 180. Once you know they all do, you're good to go. Those are the solutions. You've just solved the triangle. And so again, here we go. We have here another one. Let's look at it. We're just going to draw it. Again, I could put A anywhere I want. Any of the acute angles A and B. We name C the right angle. And so again, I have little a, little b, and little c. Now, when I go to the givens here, I'm going to look at what they've given me. They gave me side A is 958 meters. And they gave me side B is 489 meters. And they want me to solve the triangle. So here I'm going to have to find some angle measures. And so it's great because we're going to have to use something that we haven't used before, which is our inverse. But before I start, I'm going to do the Pythagorean theorem to find side C. Because again, remember, Pythagorean theorem always works if I have two sides of a right triangle. So since I have the one leg, 958, I have the other leg, 489, I'm going to be able to use my calculator and figure this out. So 958 squared is 917764. 489 squared is 239,121. I'm going to add those together. So 917764. I get 1156885 equals c squared. And when I take the square root, I get that c is approximately equal to 1075.6. So it's approximately 1075.6 meters. Okay, so I have side C now. So now if I'm looking for angle A or angle B, what I'm going to have to do is do the inverse, okay? Because again, we know the sine of, let's say, angle A equals the opposite over the hypotenuse. That's easy, right? So the sine of angle A equals 958 over the hypotenuse 1075.6. So that's easy enough, right? But the problem is that what this is telling me is what the sine is. It's not telling me what the angle measure is. But if I do what's called an inverse function, inverse sine, if I do sine to the -1, or I do second sine on my calculator of this fraction, 956 divided by 107.5.6. If I do the inverse sine, it's going to tell me what the actual angle measure is. So go to your calculator, you'll just do, however your calculator works, you might have to do second sine and then insert 956 divided by that. Or if your calculator's like my iPhone calculator, you're going to do 956 divided by 1075.6. You're going to get some decimal. Let me tell you what the decimal is. You're going to get 0.8888, and then you're going to do inverse sine, and you're going to get 62.72, which means angle A equals 62.7 degrees. And so we were able to find the degree measure using the inverse sine. Anytime you're looking for degree, that's how you have to do it. Now that I know that A is 62.7, I could just figure out that angle B equals 90 minus 62.7 without having to actually do any more trig functions, okay? And I'm going to get 27.3. So 27.3 degrees for angle B. I could also have used it, using cosine or something else, and, inverse cosine or whatever, but this is obviously the easiest way, and you do want to work and be the most efficient. Okay, so for this problem, these are our answers. We have angle A equals 62.7 degrees, angle B equals 27.3 degrees, angle C is always 90 degrees. Little a was given at 958 meters, little b was given for 89 meters, and little c was calculated using the Pythagorean theorem. And so these are the solutions to the triangle. And then we'll go and do the last one, which is going to be very similar, because again, this one, again, I'll label my angles, angle A, angle B, and angle C, and then my sides, little a, little b, and little c. And I'll plug in what I've been given. Little a is 26.5 centimeters, and this one, little c, or the hypotenuse, is 39.7 centimeters. And so yet again, I'm going to solve this using Pythagorean theorem. The only difference is instead of being given the two legs, I'm given a leg and a hypotenuse. So be very careful, okay? So let's solve for this. So again, I've got a squared plus b squared equals c squared. A is 26.5 squared. B squared, we don't know. And c squared is 39.7 squared. So again, I'm going to go to my calculator, make sure my numbers match with yours. I'm going to do 26.5 squared is 702.25 plus b squared equals, and then it's going to be 39.7 squared. That's 1576.09. So I'll subtract 702.25 from both sides. I'm going to get that b squared equals 702.25. I'm going to get that b squared equals 873.84. And then I'm going to take the square root of that. So b equals 29.56. So b is approximately equal to 29.6. So again, remember that what we're looking for here to solve this problem is angle A, angle B, and angle C. And we're looking for little a, little b, and little c. So again, we were given little a, we were given little c, or side c, however you want to call it, and b we just calculated was 29.6 centimeters. We already know that c is 90 degrees, or angle c, so we have to find angle A and angle B. So again, let's say I want angle A. I know that the sine of angle A is going to equal the opposite over the hypotenuse. And again, I pick sine because side A, this opposite, was given to me. I don't want to use my calculation of B in case I made a mistake, okay? I would prefer not to. So I know the sine of angle A is going to be 26.5 divided by 39.7. So how I find the degree is if I take the inverse sine of this value, okay? That's going to give me angle A. So again, you're going to come to your calculator, and again, depending on how you do it, 26.5 divided by 39.7. You're going to get that decimal, and then you're going to do inverse sine of that. Again, your calculator will have different orders, but if you did it right, you should get 41.87, which is approximately equal to 41.9 degrees. So A is 41.9 degrees. And then angle B, I'm just going to solve by doing 90 minus 41.9. Right? And so that's going to be 48.1, I think, but let me just do the math to make sure that I'm not messing up here. 90 minus 41.9 equals 48.1. So angle B is 48.1 degrees. And this is how you solve your triangle. Okay? These last two slides, you're going to find in a separate video. Okay? This is going to be found in the 5.3 video, okay, part C, okay? So these are not going to go in this 5.4 video. Again, this slide is not going to be in this 5.4 video. You're going to find it in the 5.3 video, part C. So if you go to YouTube, look for that one, and you'll have these slides.